Hi kids. All right, next up we have we're now moving from 2 dimensions into 3-dimensional stuff. So what we're going to learn today is volume. So this is kind of like if I was looking at this water bottle. Volume is how much is inside the water bottle. Okay, the amount of space contained inside this water bottle is the volume. So if you hear right now, the volume is filled with liquid. Okay, sometimes your volume can be air or sand or whatever's on the inside of something. Chocolate, ice cream, orange juice, yogurt. Okay, volume is on the inside. So the water represents the volume right now. It's okay, how much space is on the inside. So just to make sure you know the difference. Volume is how much space is contained in something. So we're going to learn about all the different formulas for volume. EQ. What is the general rule? General. We're finding volume. Okay, what is the general rule for finding volume? So we're going to deal with a lot of shapes today, or a lot of like 3D objects. We have cubes, rectangular prisms, triangular prisms, cylinders, cones, spheres, and pyramids. We got lots going on. So before each time we do it, every shape has every object has its own formula, but there is a basic rule of thumb that you can use when doing volume. So let's again remind ourselves is the space inside a 3D like object. Okay, example, it's the water inside a water bottle. Water in, water bottle. Okay, like draw Mrs. Minch's water bottle. Has blue liquid in it. Okay, it's the blue. It's the space, it's the stuff inside. Okay, inside the water bottle. How much space is contained inside of it? So there is a general rule of thumb. Rule of thumb is a phrase that adults use. I mean, kids can use it too. There's a general rule of thumb, okay, for prisms or shapes that have the same top and bottom. You should have learned that in your last activity. So shapes that have the same top and bottom. So like a cylinder has a circle on top and a circle on bottom. A rectangular prism has a rectangle top bottom. Cube has a square on top bottom. What else? Triangular prism has a triangle on top and bottom. A general rule of thumb is it's the volume is the area of the base times the height of the object. Okay, now I don't have my like stuff at home to show you what that means, but that's a general rule of thumb. And we're going to add some stars here. Okay, because that's a general rule of thumb. That means it usually works, but the times it doesn't, we need to know that. So that's why I'm putting stars here. So this is, in general, it's the area of the base times how tall it is. Okay, so like this would be the area of the base, which this base is a circle, times how tall it is. We know how to find the area of a circle. We did that in our last unit. So area of the base times how tall seems pretty simple. For this Rubik's Cube, the area of the base times how tall it is. Okay, this is a cube. Area of the base times how tall it is. John, could you hand me that box, please, for my lesson? I'm sorry. Yes, thank you. For this, guys, thank you, John. This is a rectangular prism. My sister made this in woodworking class. Okay, area of the base. So the base is a rectangle. I know how to find the area of a rectangle, length times width, times how tall it is. Okay, so volume is area of the base times the height. But the only exceptions are when they come to a point. When it comes to a point, you need to divide your answer by 3. So if it comes to the point, you need to divide your answer by 3. So an example of an object that comes to a point would be like if I was to make an ice cream cone, okay? It would be the area of the base, which is a circle, or in that, okay, times how tall it is, and then you divide by 3. So it's the same premise, area of the base times how tall it is, but then you have to divide by 3 because it's not taking all that volume in. Think of like the pyramids, okay? All this stuff I have at school, I don't have it here. Think of the pyramids, okay, that the Egyptians have. You take the area of the base times about how tall it is, and then divide by 3 because it's not taking up all that space. Okay, so we're going to go through each shape. I'll give you the formula and I'll do an example with you, okay? So let's start with a cube because it's kind of our simplest one. Oh, sick. John's awesome. He could hear me. Here's a pyramid. We would find the area of this base. This base is a triangle. So 1/2 base times height times how tall it is. Okay, I'd have to find the measure on the inside, how tall it is from the top to the point. And then I would take that and divide it by 3. So pyramids you divide by 3, or cones you divide by 3 because they're going up to a point. Okay. All right, let's go ahead and get started. So our first one we're going to deal with, like I said, is a cube. So before we begin, if it's just the area of the base times the height, we need to define what the base is. So I'm going to do that for each of these. We're going to write up top base. We're going to write formula. And then we'll have here like other interesting info. So the base. So we're going to put the base shape. We're going to put the formula and then other important info. Base, formula, other. So our first one we had was a cube. So in this cube, this base, okay, the base, what it lies flat on is a square. So let's just write square. Okay, so the formula is the area of the base, so the square times how tall it is. Well, what's unique about cubes is its length, width, and height are all the same. So its volume is the length to the third because you're doing the length times the length to get the base times the length to get the height. Okay, let's keep going. We'll do examples at the end. Okay, I just want to get these all in the same spot because you know me, I like everything to be organized. Next one I'm going to do is a rectangular prism. And that's like this box my sister made for me. So the area of the base, what it's lying flat on, is just a rectangle. Okay, you see that's just a rectangle. That's where it gets the name rectangular prism. And its volume, if we're doing the area of the base, that's just length times width times height, how tall it is. Okay, that's it, guys. I mean, it's the area of the base times the height. It's kind of cool. Okay, let's move on to this, and let's pretend that this top's not here. Oh, John, can you hand me my LaCroix, please? I'm sorry. So this is kind of funky because it has a lid and it like curves up. And of course, cans, none of this, thank you. None of this is going to be perfect. But this LaCroix can is a cylinder. Its top and bottom are circles. Okay. So here, this is called a cylinder, cylindrical cylinder. Okay. Its base, we talked about that. What you can see on the bottom is a circle. So the formula for volume is the area of the base. The base is a circle. The area of the base, the area of a circle is pi times radius squared. Area of the base times the height. That's it. So we'd have to find how tall this can is, times it by the area of the base. Little LaCroix break. I love the coconut ones. They're so good. Okay, let's do another one. Do we have any Toblerone, John? No? Okay. Another image that we need to do is called a triangular prism. Yeah, I think my siblings ate them. If you've never had Toblerone, it's chocolate from, I think, Switzerland, and it's really good. It has like chunks of stuff on the inside. Oh gosh, yes, it would come in handy. Toblerone is a triangular prism. Triangular prism. Okay, this is called a triangular prism because if you look, the base is a triangle and the base is a triangle. Okay, triangular prisms have a base and top that are triangles. If you notice, the sides are just made up of 3 rectangles. Kind of cool. That'll come in handy when we do our surface area in the next video. So, area of the base. Okay, the base is a triangle. Can be any size. This one happens to be an equilateral. That means all the side lengths are equal, but it doesn't always have to be that way. The formula is the area of the base. Remember volume, area of the base times how tall it is. The area of the base is 1/2 base times, we're going to call this little h. Now that's going to go here. Little h is the height of the triangle. Triangle height. And remember, we learned that triangle heights are from the top down at a 90-degree angle. It would not be the slant height. That's called the slant height. That gets you the perimeter. It does not get you the height. So area of the base times height. Then we have to times it by the height of it. So this one's weird because the little h means the triangle height. The big H means the prism height. No, it technically doesn't matter because you're just multiplying them together and order doesn't matter in multiplication. But if you're like, why do I have two heights there? It's because the area of the base is 1/2 base times height times the height of the prism. 1/2 base times height times the height of the prism. Okay, so that gets you your volume. Okay. So just to kind of recap, we have a rectangular prism. That's like what you call a typical box. Okay, now you can call it a rectangular prism and sound mathy. You have a cube where all the side lengths are the same. You have a cylinder, which is like a Coke can or a sound like my grandparents, or a like a can of soup. And then triangular prism is like Toblerone, or sometimes they send stuff like packages in this shape. Okay, so that's where we're not even close to done. That's just 4 of our shapes. I'm going to mark them off my list though, so I can be like check, check, check. So we got cube, rectangular prism, triangular prism, and cylinder. All right, next we're going to go to kind of the funky ones. Now this is an 8th grade standard, but I figured you guys can handle it because it's just one more. So next I'm going to go to sphere. Okay, a sphere, I don't need to show you an example of a sphere. You've used spheres your entire life. In PE, you've used them when talking about the solar system. You've used them with dodgeball. A sphere is like a 3D circle. It's a ball, tennis ball, racquetball, golf ball, any of that. Okay, that's a sphere. Okay, so sphere doesn't have a base. Oh, John's gonna throw me one because he's listening. So sphere, little sphere. Okay, so it doesn't really have a base because it doesn't rest on anything. There's no edges, but we're just gonna say it's circular. Okay, circular. We don't need to write the rest down. Yeah, these are erasable. Okay, so the formula is different for this. This one's a weird one. You don't divide by 3, but it's a weird one. You're gonna do 4/3 times pi times the radius cubed. 4/3 pi r cubed. That's just a weird one. You'll learn more when you get into geometry where that comes to be. You can actually watch some pretty cool videos on it too. But the sphere for volume is 4/3, 4/3, times pi times the radius. Now I can't find the radius of this. I'd have to break this and find the diameter and then go halfway across to find the radius. But yeah, 4/3 pi r cubed. Just a weird one. Now we're gonna get into the pokey things that you have to end up dividing by 2. So now we're gonna get into the pokey things where you divide by 2. So we're gonna go with cone. Okay. So a cone is like an ice cream cone if you had a waffle cone. And I do not believe we have anything like that here. Can you think of a cone, John? What? Do you think we have a cone? Yeah, I don't think so either. So if I was to get a waffle cone at the ice cream shop, okay, and it was like this, its base, what it rests on, is typically like a circle. So it has a circle base. Okay, and it's times the height of the cone. Now the height of the cone is not the slant height. This is called the slant height. The height is from the bottom with a 90-degree angle right up to the top. Okay, so let's pretend it's like a normal one. We're gonna say, okay, if it's the area of the base, the area of a circle is pi times radius squared times the height. That gives you the volume. But then remember, I said if it comes to a point, we have to then divide that whole thing by 3. Okay, and let's put a little note here. It is the true height and not the slant height. We got to remember true height. Okay, now we're on to our last one. Now this one's a little bit wrong. I love that John got this for me. It was sweet, but we are not learning about triangular pyramids. In 7th grade math, you only learn about rectangular pyramids, like the real pyramids like in Egypt, but it was nice still that he got it for us. So just pretend this has a rectangle base. So the last one is going to be rectangular pyramids. really doesn't actually change it that much because your area of your base is just a triangle, which you can do that. You know the area of a triangle is 1/2 base times height divided by 3. So it's really not that hard. So you could do it, but technically speaking, you don't need to know it. All right, so we're doing a rectangular pyramid. And why they call it a rectangular pyramid is because the bottom is supposed to be a rectangle. So I think some of you could guess this would be a triangular pyramid because it has a triangle as its base. So a rectangular pyramid is going to have a rectangle as its base. Okay. So let's just keep going. We know that the volume is the area of the base. Well, the area of a rectangle is length times width. Okay, then we know it's the area of the base. I keep repeating this so it drills into your head. Area of the base times the height. But because it comes to a point, think of all if we just did times height, that would be like this. Okay, but we don't have that. We have it split. It's the same thing. You just divide your answer by 3 when you're done. Okay. All right. So, and again, this is the true height, not the sling height. Okay, what I mean by true height is if I was to have this pyramid here. Okay, the true height would be from the bottom straight up to the top. Okay, true height means straight up from the bottom to the top. Okay, I'm going to pause the video now. So now we've learned all the formulas. Now the next video we're going to do is actually using them in story and just in problems. Okay. Well, let's go through it one more time. So the formula for volume, because volume is the inside, it's inside this Coke can, it's the stuff inside this Rubik's Cube, it's the coasters that we have in that. Inside this would just be, sounds like there's something in there, but it's just air. Inside this is chocolate. I think this is the best volume out of all of it, okay? So volume, for most things, is the area of the base of the object times how tall it is. But if it comes to a point, we do that same thing and then divide by 3. So for a cube, the area of the base is a square. So length times height, which is the same thing. So length times itself 3 times L to the 3rd. Rectangular prism is the area of the base. The base is a rectangle, length times width, then times that by how tall it is. Area of the base, length times width, times height. Cylinder, area of the base is a circle, pi r squared, times the height. Triangular prism, area of the base is a triangle, 1/2 base times height, times its true height, how tall the object is. Sphere, 4/3 pi r cubed. Just you got to remember, it's one of those weird ones. 4/3 times pi times the radius, halfway in between the circle, to the 3rd, times itself 3 times. Okay, so just the radius though, because you know how to do powers first. Cone, like an ice cream cone, a waffle cone, those snow cone cones. They're like cone dunce hats they used to have people wear. What are other uses for a cone these days? Just say ice cream cone, because you know I like ice cream the most. So area of the base is a circle. Whenever you put that little nice spherical ice cream thing, it goes into the circle. So area of a circle, pi r squared, times how tall your cone is, but then you have to divide it by 3 because it's coming to a point. And then rectangular pyramid, like this, but pretend it has a rectangle. So the area of the base is length times width, then times it by how tall it is, height. So length times width times height, but then it comes to a point, so you have to divide by 3.